Okay, so we'll go ahead and get started. This week we're going to cover Unit 3 or Chapter 3 of the course. And you can find the notes in Canvas, and also we are going to go through the assignments together. And then after that, we will work on the lab. Again, today we're going to use Kali Linux. It does take a little bit of time to download. So if you want to download that while we're working on this, or you can do that before we go to break today. Oh, sorry, I grabbed the wrong class. Give me 1 second. I grabbed 27A instead of B. I should put this on my this. I should put it on my cloud drive. Let me close some of the other file. Okay, so today we're going to talk about banner grabbing, OS fingerprinting, and work on reconnaissance for the web server. I think we've used some of the reconnaissance tool, and we have touched on like web server installation and services in the prior lab. So we will continue because it is an easiest way for you to kind of set up a simulation of the real world environment when you set up your own web server and trying to perform reconnaissance tasks with that. So in Unit 3, we will look at how the server is responding certain requests, and we'll come back to how banner is being used. And banner grabbing is a very common technique for pen testing, especially when you're dealing with public-facing servers like web servers. So when you have a request from the client, let's say that you're visiting a website, right? You normally type in your URL. Your web server would receive that request from the client, but in that you would have the TCP handshake. So when you're understanding your server response, what happens is you do see some of the sub-process that's happening, and the attacker would do the same, right? From an attacker standpoint, they would break it down into the sub-process and really understand what is being given back when you're submitting that kind of request. So when we're looking at this picture, right, your browser, when you type in your URL, it's going to submit that request to your web server. But within that, it's going to look up DNS, okay? And it's going to, I don't know why it keeps sliding that lock, so let me fix that. And then in the case that if you have a redirection, let's say that I had moved the hosting of my website to another, let's say, company or a physical server elsewhere, right? You can have a redirection. But in the case that we're connecting, after it does the DNS lookup, it's going to then attempt to connect, because TCP doesn't allow any kind of response back unless there's an affirmation in the connection that is established, right? We know that through the TCP handshake. So when you're using HTTP or HTTPS, that's under the umbrella of transmission control protocol, that means that it has to have confirmation that things are connected before it presents you with that web page. So therefore, once we are connected, right, and then we're able to retrieve the information from the web server. So the web server job is to do what? To give you the web page content, website content. But it is not the actual domain structure, the DNS. Its job is to actually give you the domain, the URL, right, conversion to the public address. That's what you see. So these two are going to work hand in hand. Now, from a development standpoint, in web development, we will look at this, right? And the networking standpoint, the server response time is, it's going to be dependent on two areas. How good is your network throughput, right? That can come back to your infrastructure in your network. And then from a development standpoint, how good is your page load time? That really depends on your web content in HTML, JavaScript, and other languages like Go or Node.js, etc., right? Depending on the content there. So when it's loading the content that's being pulled from the web server, right? The web server has the file that it needs to be able to give you the page, right, that you see, or the video that you see, etc. So the content download, and it's going to load DOM, right? So in this area, we're going to come back here and we're going to look at how, right, attackers utilizing this for web server attack, and then it's going to load the page. In the case if we're using cookies, secured session, all of that is going to be happening with encryption, right, in this area. So when you're doing pen testing for a particular server, you really have to break down in what's happening, right? What type of steps in the communication between the systems to really see what areas that you need to tap into to obtain information, or to utilize a certain tool to be able to perform certain type of attack if you're looking at ethical hacking, right? So let me get to the assignment here. So for the first question, it asks you, why are web server responses important? Because the responses are going to contain information about whether your connection and the request is successfully established, right, or failed. So in the case where if I connected and I'm successfully communicating and obtaining the content from the web server, it's going to generate a status code, which is 200, right? And then you see this when you type in the URL of maybe a bad domain, right? It will give you an error code. Or if it is an incomplete URL, a link that you put into your browser, it might give you a 503 or 404, right? So in the failed connection, it's going to generate some kind of error code. Why is that? Because you're using TCP. If you don't use TCP, if we use UDP, you won't get anything actually, right? It's just going to happen, and so be it, right? But in TCP, there has to be some kind of confirmation that your connection is established. There's communication between your client saying, hey, I'm now connected. Can you give me the content? And the server said, yes, sure, here it is, right? So there has to be some kind of handshake between the system, right? Now, from a standpoint of technical support, right, or web administration, it's really going to help us understand how to fix the problem for troubleshooting. And then in development, right, I mentioned to you earlier, if we're looking at web development, we want to see the performance in the content when it's loading. And then from a networking standpoint, how fast is our system communicating, the throughput, and then the number of requests and response time from our web server. So in the case, if you're looking at, you know, a company like Amazon, you cannot have too much of a delay because, you know, time is money. If you have a huge amount of flux, let's say Black Friday sales or pre-Black Friday sales, you want your server to be as responsive as possible, okay? And then the security improvement, this is where our professional areas is going to tap into, right? What kind of issues are we facing, the vulnerability in that particular web server, in the operating system or the services, right? So I mentioned this to my last night class. In web services, you're only going to have like some major areas. The majority of the web servers out there you see, they're Linux servers, okay? And that uses Apache, okay? Apache 2 currently. And then you have the Windows server that will be your IIS, right? So now, are these services perfect? No, right? We know that software has flaws and so is hardware. So when we look at the vulnerability in operating system, which is what we find from Banner today, right? You would see that, you know, you have to really think about how this is going to reflect the security posture, right, of our network environment and our system. Okay. So for web response status code, right, I put a link here and you can go to that link. So I'm going to do control click and I'm going to open the page and I'll come back to the answer. So this is very useful. You will need to know the status code for this class and also maybe other classes that you might be interacting with web servers. Could be your coding class like JavaScript, or if you go into other security classes that you work with web server, you need to know the status code. Some of you are familiar with this because you might have read documentation or use it. So when we're programming, a lot of the times on the back end, right? Some of you think about like administration on the back end. You see status code all the time. Your system is going to tell you if it's doing okay or not, right? So in the case, if I'm developing, I wanted to see if my web server is responding correctly. So you have to do some tests. Now, if the system is only going to give you the information, right? It's going to be 100 to 199. And then any kind of successful response that's going to follow into this range. And you can click this and it's going to give you the breakdown. And then redirection, you tend to see that in the 300s, right? And then error is 400, and then 500 is the client error. That's your browser, your URL error. And then the server error, let's say that my server crashed because denial of service attack. And then if the client is trying to reach me, right, you're going to get server error. So, or if it's too busy or if it's down, right, you're going to get the server error response in the 500. But if you type the URL wrong, that's going to be in the 400s. Okay, so that's on the client side, or maybe the browser is corrupted, something like that. All right. Okay, so I know that this is long and you can always use the link. Okay, so I want you to know the status code because it's going to be useful when we're doing our lab and then also future, technical setup. So you can always go to the link and then read each of them. So if we're looking at code 102, that means that the server has received and processed the request, but no response is available yet. That means that it got the information, it got the request from the client, but it hasn't started responding. So that's 102, okay? Now, sometimes this doesn't even show, right? Normally for some developer or some program, or if you're using a module, like a Python module, that a tool that's written in Python, sometimes that they're only tracking certain status. So it's like a condition. If statement is used, if it is successful, generate 200 as a value on the output. If it's not successful, generate like a 400 value. So some tools doesn't even have all of the status code, just to let you know. So you often see, you're going to see the most is 200. 200 is, that means that the request succeeded. Okay. 204, a little bit different than that. It has been succeeded, but there is some post request response or some put request. So there's additional sub-process that's added for 204. When you are moving your website, so let's say that I used to have mydomain.com and I had moved it into, I redirected into a different domain, maybe for a cheaper price, or maybe a different host. So if it is permanently changed, that's a 301. And I might use mydomain.io, right? Or mynewdomain.com. So if you change your URL completely and redirect it from your old domain, that's going to be a 301. Okay. Now, why is this important? You know that all kinds of poisoning in security does redirection, like we talked about DNS last time, right? DNS redirection, where they can change your DNS record, but you can also redirect using other techniques. So that means that when you look for the error code or some kind of status code, and it generates any kind of 300 code, we know that it is a redirection. Okay. And then for 305, that means that it's just using HTTP specification for the response, and it must be accessed through proxy. And proxy is kind of like the traffic police, right? And it's just, my analogy for proxy is you can place a traffic police at the intersection, and they would direct the traffic. Everybody goes through that traffic police to turn left, turn right, go straight. So the traffic police would see every single car that goes through that intersection. So that means that it is, it can be used as an interception point, right? So 305 is using an old HTTP version. And then 400, you often see this as well when you're doing banner grabbing. You would see 400, or in the, if you're getting error. So a server cannot or will not process the request due to client error or malformed request syntax. So if you type in like a wrong URL, or something had happened with that browser from the client side, that's a 400. 401 is unauthorized. So when you're using, for example, I'm trying to access a site that is, let's say, protected by a firewall and it's not passing my traffic through, or if I'm trying to not log in and be able to access that website, it's going to say 401, that is unauthorized or unauthenticated. And then 403, you don't have the access right to the content. So if I'm trying to access like maybe some company's information, when I click on, maybe some type of benefits or services, it might generate a 403. And then 413, which is going to be request is too large for the limit, and the server might close for the connection. So in the case of potential attack or attack that's happening, you might see 413, where it generates a lot of the requests, because denial of service attack does what? It just floods the server with a bunch of address at once, right? And so distributed does the same thing, but it's coming from different sources. compared to, you know, denial of service only, then that's going to be direct target from client. And then, you know, there might be a reattempt because in our system, right, with TCP is that it notifies you that something goes wrong if the connection is not established. So therefore, right, the status code is going to then be generated. But you can also reattempt by reloading. And if it also exceeds the limit of the connection again, if it requires too much bandwidth, then it's going to withdraw. So you're going to see a 413. So as we understand, right, how the system is responding and what's happening between the client and the server, we would have a better picture of, you know, where, at what step can we find the information and why is it responding this way? Okay. Okay, I'm going to scroll down a little bit so we can see the next one. So I'm going to obtain the web response today through banner grabbing, okay? And the web server is going to give me some kind of information. Now, you're going to have header for HTTP header, just like many of you are familiar with header and footer and for packets and services, right? So when you look at that, that basically tells you what? The header tends to only have like where it's coming from and where that's going to. That's like the label to your mailing package. Let's say I need to send my friend a present, right? That's the label that goes on top of that present, who that's going to, and where that's coming from. Now in the body, what you're going to see is you're going to see payload, right? In network traffic, we look at that as payload. So in the web server response body, think about HTTP, that's going to be the data for the client request. Okay, so that could also be JSON file or XML. That could be data that is useful. XML, think of it like looking like an Excel spreadsheet that might have columns and rows of data. JSON file might be a little bit on a different type of format. So you might see some formatted data for the client. Why is this important? You see this with data, with scraping, web scraping all the time, where we actually, web scraping process is to pull information from a lot of server from the web and using the content, right, the formatted data for analysis purposes, okay? This is what you see for like data analytics or big data. But from a security perspective, data is asset, data is information, and data can be sensitive. So we want to make sure that when the web server, maybe it's highly private data, we want to make sure that it is encrypted and protected. So if someone can scrape the data and grab the data, then we're not doing our job, right? So we want to make sure we test this to see if someone can do that to our server and then be able to make sure we have the proper protection for our server. Okay, so the responses list, you can see there, I put the individual link for you. And the response body, you can find this on page 2 of our notes. Okay. So when you're looking at the response, right, this is the structure. Okay, because later on you're going to see a bunch of text and you're like, what am I looking at? So when the server is responding to you, there are 3 components. The status line, we already talked about those codes, 200, 400, 300. That's going to be part of the response. And then in the header, it's going to contain some detail about the response, like the type of content, the type of payload, the type of data that it's giving. So let's talk about the label for our mail package again, right? It might not say what's in that box, but it might say the weight of that box, right? If you ever go to the post office and you drop off a package to mail, right? They weight it and then they they would determine the amount of money that they would charge you. So think of that as part of the header. It's going to say, here's the type of data that is being served. Why is that important? Because an attacker might be looking for a certain type of data in XML. Okay, that could be private, right? Now, when you're looking at that, when you're doing the banner grabbing or when you scrape, you would see, okay, that this is part of the body. And then the header is going to say what's in the body. It's kind of like when you're writing a paper, you're going to say, this is the introduction and this is what I'm going to write about, right? So the way we design the system is really represent how we see and understand information. So the header is going to say, oh, it will contain this. And so you would see something like that, okay? Now, when you're looking at network traffic, you might see a get step that's at the beginning. So when you type in a URL and you click submit, visiting that website, the first step is going to be get, right? I'm trying to connect to that web server and get it to communicate with me, so it's a get information, right? But when the server is responding back, let's say I go to youtube.com and it's giving me the page, right? Okay, and then I might want to register for an account. So I start filling out the information. When you're submitting data to the server, right? When you're registering for an account, that's a post. Okay, so when you're filling out forms, submitting that's a post. So you kind of have to really think about what's happening in between, right? Like from the client to the server system and the type of content that is sending back and forth, okay? So in the case of post, you're submitting data to the server, right? When in the case of get, right, you're obtaining maybe page content from the server, okay? So opposite. So here's the header. We talked about that. So this is smaller pieces of information, and it would tell you instruction and metadata information. So there are two types of headers. One is the request header, so that's coming from the client. And the other type of header is the response header that's coming from the server, right? So back and forth, you're going to see these components. And they often use colon as separator, okay? Okay, so the request header contains information about the resource being fetched, right? About the client, the requester, the sender, okay? The response header is going to contain the server information, the receiver. Okay, so for number 4, it says explain the purpose of HTTP headers. What do they contain? So in summary, they provide additional instructions or metadata about the server's response or the requested resource. So it's basically about the sender and the receiver. So the client and the server. It also serves as letting the client and the server pass additional information with the HTTP request or response. Let me move forward to the next page so everything's together. Okay, now it's at the top. And then third, the header would consist of case-sensitive name, and the colon is going to follow that, and then the value. Why is this important? You want to be able to see the content of it, so that way you know, and anything white space is ignored. So it doesn't count as underscore or anything like that, just white space. And you can grab this from the notes or summarize it. You don't have to write it verbatim, like I said before. So the request header would contain information about the source that's being fetched or the client, right? Your client is the request. It's going to contain information about the client for the request header. The response header, it's going to hold information about the response, like location of the server, or the server information, like its service or the type. The representation header contains information about the body, like MIME type or encoding or compression. So encoding, it would say like UTF-8, right? Or other type of encoding system. And then you have the payload header. Anytime you hear the term payload, you know it's data, right? It would contain representation independent information about payload data. That would be content length, how much data, and the encoding used for the data. Now, sometimes you would get different encoding system for the data compared to, you know, the header area for the server system. So that's why they use separate section for it. And then the general headers that would just specify the information about the response, the date, the server type. These headers are not specific to any of those other areas, and it is just broadly about HTTP message. So if anything else that doesn't fit here, it's going to fall into the general header. Understand that, just like an extra area that they have to use to give you information. So when you're using your tool, it's going to first pull the request and the response header. These tools are designed to do that. And then it's also going to pull information from the payload header, right? Because that's very visible for communications. So our systems that are being, that's communicating. And so that's what you see. Any question? Now, a lot of these tools can be designed to or be implemented for automated system, and you can also write script to do this. You know, but there are tools that already been built for you to be able to obtain, you know, like web server information from these headers. Any question? See a lot of typing, it's a lot of information. So I hope that when you put these things down, right, you would remember what they are. You know, very useful. I think, you know, in the case of you looking at vulnerability assessment and management, we kind of, we talking about pen testing, right? Pen testers tend to work, right, from the outside in. So you have to examine, you know, your public facing server, which are your web servers. And then you gradually work towards your internal network, where there are more private data and so on. So because your web servers are public facing and they have more exposure to potential attacks, and they are easy target, right? And they could also be a way for someone to funnel into the network, because if they can bypass through some of your public facing system, because those are ultimately connected to the network, but we have proper perimeter protections with those systems. So you often see a lot of like technique and tools in this area, because it's very common. Okay, so it's good to understand how to do this, right? For 6, you're gonna visit hackertarget.com, and they have a specific area for HTTP header, right? So this is the API through hackertarget.com, and then what you see is I'm looking for information, but look at my URL, right? I ultimately use google.com, so whenever that you have the URL, you think about the web server for Google that's serving you, and this is the content that I'm getting back for the data or the information I'm getting back, okay? So here is the location. And with this, we kind of have to, let me see if I can zoom in a little bit so you can see. And you can click on the link yourself and look at that at your computer, right? And then you have cache control. We talked about encoding and content type, right? You got text to HTML, and that's UTF-8. And then we would have permission policy if there's some additional information. Also your HTTP version. And remember the status code we talk about, right? Whenever you see 200, that's okay. Here's your length that really represent how much data. Think about the weight for your package that you're mailing, right? And then there's no cross-site scripting protection, because if you do search engine, right, most people just type in the search criteria. Can you inject something for it? But for what? There's no database for you to do any kind of injection for, so there's no need, okay? So now, but if you're looking at a different target, maybe a target that has a database attached to it, can that be of an issue, okay? So this is just a mean for you to see that, yes, you can use this for other type of system. And then for cookies information, so I want you to see how that would look like, right? Because we talked about what the headers are, what type of content you would be seeing. So I want you to fill out, right, each of these as you look at the information from that link, okay, on your own. Oops. Any question? Sure. Or it might have more, right? Depending on the purpose of that website, how it's created, what kind of content that is intended to give. Some website, like if you're looking at a web app, right? If you go to your bank and try to fill out information, it's definitely a different purpose for that website. So now, when you're dealing with a company that have a lot of web servers, right, and that's your scope, you're going to have to go through each one, right? And you have to dig out all of the information. So more organized you are, the better and easier your job is going to be down the line, right? So the part of Recon is to find information that we can use, okay, for pen testing. So that means that, you would, if there's 1,800 servers, we are going to do that, right? And so it can be a streamlined process or it can be a manual process. It depends. Sometimes you also have to overcome security to obtain information, because Not all web servers are going to be able to give you, boom, information right away. They might block it, right? So you have to bypass that. So there will be hurdles along the way as well. So keep in mind that it might not just be all easy and public information. Okay, any question? Okay. So kind of show you how you can also use API and then put in your target, right? Okay, so let's talk about banner grabbing before we answer 7. I'm gonna move down so that way you can see. And then there's additional information about end-to-end headers and proxies and connection headers. So I put some link for you to look at. So you're gonna see that FTP and HTTP banners are the most common that you can perform banner grabbing technique with. So to simulate this to practice, the easiest way is to put up a virtual machine that runs the web server or the FTP server. I just went over FTP server with my class last night for 41A, and I also do that in this class and other classes as well. But what you can do is just put that up and then use the same machine or a different virtual machine to attack it. So I can run a Kali, with the web server, right? I just set it up to loop to connect as a virtual network and then use another Kali to attack it. And this is how you can practice, right? Or you can, what we do in this class is we attack ourselves within the same system. So for FTP banners, their information again about connection, right? About the server and the client information. With that, we want to determine the vulnerabilities of the systems. That's ultimately the goal in pen testing, or if you're looking at the attacker, right? Because they want to capitalize on the vulnerability for exploitation purposes, okay? So for 7, the purpose of banner grabbing in pen testing is to provide information about the server software. That could be operating system that server is running. The services, like I mentioned, IIS or Apache for web services. Why is that important? Because outdated version or current version also have flaws. And these flaws can be used for exploitation from an attacker standpoint, right? When we pen test, we need to find that, because that information is going to help us understand how we're going to be better at patching or updating our system, or perhaps thinking about planning to integrate a different type of service, right? Or a different operating system down the line. We might not be able to rip out everything and install right away, but we can project on how we can plan out this project so that way we improve security. Ultimately, that's your job. Find the holes and patch that hole, cover that hole, fix that hole, right? So we want to remediate, and sometimes what if you cannot? What if there's no fix for it, right? So that means that you have to accept that risk. But you, as a pen tester or an analyst, you have to report this, right? Because it's going to come back and say, hey, you know what? We paid you to do this to find the problems, but you didn't tell us the problem. So we were never, budgeted the money to fix it. So now it becomes your responsibility and your problem, right? You might lose a job because of it, or, so there are repercussions behind that. So our job is to report the issue, and if you also report the fix for the issue, if you're able to identify the fix for it and recommend it, or not, if you don't have a fix for it, you still have to report, but you have to find alternate way to go about, improving your security posture. And in that section of the FTP server, you can obtain the operating system version, right? Whether it's running Linux or Windows. or other type, usually just with Linux or Windows. So what tool should you use? So in order to grab banner for FTP, these are the common ones that you see. Nmap, right? Vulnerability tester, software that we would use, okay? And we know that Kali is equipped with Nmap, but in Windows environment, so let's say that I'm using my Windows laptop, I can go to nmap.org and download ZenMap, which is the Windows version. It is more user-friendly because it has things that you can click, right? And then we can use Netcat. This is Nictol, sorry, I had a typo here. It's a T. So whenever that you see, whenever that you see web services like HTTP, HTTPS web server, you're gonna have a common set of tools, right? So vulnerability assessment tool, you can use Netcat. That's gonna give you also information about the system. Now FTP is similar to HTTP in the fact that we can use the web environment to allow the user to upload and download file for the sharing purposes or distribution purposes and so on, right? And this is like based on your common FTP port 21, and we specifically just look at that service for now, not SFTP yet, okay? And then you can use curl, but curl can be used for a lot of things from downloading to, you know. And wget is the same command in Linux for if you need to visit a website and download. But when you visit a website and try to download, you're really accessing all the processes, right, in web services. That means I have to do a get, right? I have to obtain connections, establish connection, and then be able to obtain the data from the web server. Now, Telnet might not be feasible all the time because by practice, right, in security, we disable Telnet. Why is that? You guys know? A lot of high school students, when they go through cybersecurity training, that's usually we talk about Telnet. Telnet is a way that we can do what? I can use Telnet to do what? To connect, right? Like I can connect this computer to this computer using Telnet. I can connect this computer to my router using Telnet. But I can do that with SSH. What's the difference between Telnet and SSH? Right, Telnet is less secure because everything is in plain text. It's visible, it's not encrypted. SSH is better because it uses encryption, right? So now all technician and administrator